For this lesson, we will look at optimization. Now, optimization is basically finding the extrema, the maximum or the minimum point. Now, in the previous lesson, we have learned that we have to use the first derivative, f prime, to find where the function is increasing and decreasing, and to find the maximum and the minimum point. And we have discussed about the local or the relative maximum and minimum. On the other hand, the second derivative, the f double prime, tells us where the function is concave up or concave down. It also tells us the point of inflection. And the point of inflection is where the graph changes concavity. Okay, taking this in and applying it to optimization. Okay, let us take a look at the following problem. Now, this time, okay, I want you to take note that we want to find the absolute, okay, the absolute maximum and the absolute minimum value in a given interval. Okay, so you can only find the absolute if you have a closed interval. So take a look at this problem. Find the absolute maximum and minimum of the function f of x equals x cubed plus 3x squared minus 9x plus 7 on the interval from -6 to 0. Okay, so we're finding the maximum and the minimum, which means that we have to find the first derivative. So we get f prime of x, and the derivative of f of x is 3x squared plus 6x minus 9. Now remember that when you get to find the maximum or the minimum, we have to set the derivative equal to 0. So we take this derivative, 3x squared plus 6x minus 9, and set it equal to 0. So in this case, we can factor out the 3, or we can divide everything by 3. Okay, and that gives us x squared minus 2x minus 3 is equal to 0. And from here, we can factor. So we have x minus 3 plus 3, x minus 1 is equal to 0. So we got two values for x here. We have -3 and +1. Now, taking a look at the interval, your interval is from -6 to 0. So -3 is within the interval, but 1 is not. So that means we can discard 1. So this is discarded because that is not within the interval. Now, if we're finding the local or relative maximum or minimum, then you can just say -3 could be the relative maximum or minimum. But here, we want to find the absolute. So in other words, when you find the absolute, you have to test including the endpoints. So here's how, this is called the candidates test. Okay, this is called the candidates test. Candidates test. Okay, meaning we have these x values right here. Okay, the endpoints, -6 and 0, and the critical value that we got here, which is -3. And then we want to find the value of the function at each of these x values. Now, whichever gives us the highest value, that's your absolute maximum, and whatever gives you the lowest value, that's the absolute minimum. So how do we find it? Okay, we have to use or to evaluate the function, the given function, this f of x here, at each of the values. So f of -6 will have -6 cubed plus 3 times -6 squared minus 9 times -6 plus 7. So we'll evaluate the function at -6, and we will get -47. Then you do the same thing. You find f of -3. So you plug in -3 for x, and you will get 34. Next, you plug in 0 for x. So if you plug in 0 for x, you will get 7. Okay? So from here, the absolute minimum is the lowest f of x value. So we say the absolute minimum is the point -6, -47. And the absolute maximum is the highest value for y, which occurs at 34. So the absolute maximum point is -3, +34.